Hello mga ka-Johnny! Welcome back to my YouTube channel. Again, this is Sir Robin Sanipulan, your partner in learning mathematics. Before you proceed in this video, do not forget to click the subscribe button, give me a thumbs up if my video helps you. Okay?
Welcome back to my class. Again, this is Sir Robin Sanipulan, your partner learning mathematics. Okay, in this video, we will be talking about the introduction to rational function. Okay, so this is the same concept that we've discussed before. That is a function, but another type of function. And this type of function is what you call rational function. I do hope that before you come in this video, you still remember how we define function. Again, the function is simply the relationship of independent and dependent variable, or simply the x and the y, or in every input we expect some unique output, and that's how function work when we consider it as a machine. Okay, so that's how we define function, ladies and gentlemen. Okay, so the purpose or the objective of this video, we will be knowing more rational function, and we will also familiarize those consideration when and how can we say that this type of function is considered rational, and of course, and we will remember those consideration in naming rational functions correctly. Okay, so now let's begin doing this one. Okay, so by definition, a rational function is a function in the form of f of x. We all know that f of x, that is a representation of any function. So f of x is equal to p of x all over q of x. So as you can observe, always remember when you consider a rational function, it is always in this form, p of x all over q of x, where p of x here, where this one, p of x, and q of x here, these are also functions. So we have two functions in a rational function, that is in the numerator. We have also a function that is in the denominator. Basically, we have a function at the top part, and we have also a function at the bottom part. So simply it says, it tells us that rational function, this is a function that is in a fraction form. Okay, so that is a function that is in a fraction form. So basically, when you encounter a function that is in a fraction form, where we have the numerator and we have denominator, basically it tells us the first criteria that is the first criterion that is a rational function, ladies and gentlemen. So that's the thing, that first thing that we need to remember, where again, where p of x, or your numerator, and the q of x, or your denominator, it should be polynomials, ladies and gentlemen. Okay, so the first thing that you remember about rational function, that is in the fraction form, we have a numerator and we have a denominator. Okay, the second is your numerator, or your p of x, and your q of x, these two things here, it should be polynomials. Okay, so if your q of x, or either of these two, is not a polynomial, because we are using here n, so meaning it should be both your numerator and denominator, it should be polynomial. So how do we define polynomial, ladies and gentlemen? We define polynomials considering our terms. Okay, so make it sure that your term has only positive integers. Say for example, I have here x is equal to 2. So basically that is polynomial. If I have here x is equal to 1/2, basically this is not a polynomial, because my power, or my degree, is no longer positive integers. So meaning, when you consider that thing is a polynomial, make it sure that your exponent of your all the terms, it should be positive integer. Okay, it should be positive integer. Other than that, term couldn't be considered polynomials. Again, why we are keep on remembering that these terms should be polynomial, because that is the second criterion of our rational function. The first thing, it should be in a fraction form. We have a numerator and denominator. Second is your numerator, or your p of x, and your q of x. These are function located in the numerator and denominator, and this function should should be under the standard of polynomial function. When you say polynomial function, make it sure that the integers or the degree of all the terms of your functions are positive integers, meaning it should be positive, not fraction but positive. Okay, so that is the second criteria in identifying that that is a rational function or not. Second here is make it sure that your q of x also, your q of x is not equal to 0. Where is your q of x here? In short, your denominator or your q of x, that is the third one, meaning your denominator, that is denominator or your q of x shouldn't be equal to 0. In short, make it sure that your rational function, your denominator shouldn't be equal to 0, because once your denominator is equal to 0, that is no longer rational function. Okay, so because we believe that in every number, okay, so every number we consider only numbers when our denominator is we have value. Okay, we have numbers less than or greater than 0. Once the denominator becomes 0, that is no longer considered number. Okay, that is undefined. Okay, that is undefined, so we don't want the rational function be undefined. So make it sure that your q of x here or your denominator is not equal to 0. Say for example this one, I have here 1 over 1 over 2 or 1 half. So basically, this is still rational because I have a numerator and denominator, and these are polynomial or constant function. Okay, so but this one, example 1 over 0, as you can observe, my denominator here is 0. So basically, this is undefined. Once your denominator is 0 or undefined, that is no longer rational function, ladies and gentlemen. So these are the things, or these are the our criteria in making or in assuring that we are dealing rational functions. So you have to remember these three. Again, make it sure that your rational function or the function that you are dealing to consider it rational is that it's in a fraction form. We have the numerator and we have the denominator. Second one is your numerator, or we assume it here as p of x and q of x, because our numerator and denominator, these are still functions. So make it sure that these are polynomials. When we say polynomials, we have a positive integer in the degree or in the power of our terms in the given rational function. Third one is making sure that your denominator or your q of x or the function below the bar line, it shouldn't be equal to 0. Okay, once your denominator is equal to 0, that function will become undefined. Okay, so basically from the word itself, undefined, you cannot define what is exactly this rational function is. Okay, so make it sure that your denominator or your q of x is not equal to 0. So this is how we define rational function, and I do hope that you will remember all throughout these things. Okay, so that is rational function, ladies and gentlemen. Okay, say for example this one. So let's identify if this example, the function of y is equal to x plus 2 all over x plus 5 is a rational function or not a rational function. So let's try to identify this example using the criteria that I presented to you earlier. First thing is this one a fraction form? Obviously, I have here numerator and denominator, meaning automatically criteria number 1, that is checked. Okay, so for criteria number 2 is our q of x or our numerator and our this is p, I'm so sorry, p of x and q of x are in the polynomials, are our numerator and denominator are polynomials. Basically, let's observe our problem. Okay, so as you can observe, you simply observe those terms that has variable if it is polynomial or not. As you can observe, I have here x, which is a raised to the power of 1, and I have also in the denominator x, which is raised to the power of 1. Basically, the degree of these terms, both numerator and denominator, are positive integers. So basically, our what do you call this one? Our numerator and denominator are polynomials. So meaning it is under the criteria number 2. Okay, so this still check for these two. And for the third one is our q of x is not equal to 0. Basically, our denominator, our q of x, is not equal to 0 because we have here x plus 5. So still, it is under the third criterion. Okay, so it is check for criterion number 1, and that is check for criterion number 2 and number 3. So basically, this example, or our function y is equal to x plus 2 all over x plus 5, that is still considered rational function. Okay, so that's how we do it. That's how we remember this thing. Okay, so make it sure that it is under these three standards. One, it is satisfy these three standards. Automatically, the function that you are dealing is a rational function. Okay, so let's try more example to really understand how it is going. Okay, so now, as you can observe here, it is stated here, we have here a function. I have here a function, y is equal to 3x squared plus 5, and it says here that it is not rational function. Why this function is not a rational function? Let's try to check according to the standard that I presented to you. Okay, so standard number 1, that is, it should make it sure that that is in the fraction form. Is this function in the fraction form? Basically, we have a numerator and we have the denominator, meaning for standard number 1, that is check. How about for standard number 2? For standard number 2, make it sure that your numerator, or your p of x, and all over q of x, or your denominator, these are under polynomials. Okay, so when you say polynomials, that the term, or the power in each term, it should be positive integers. When you say positive integers, meaning that is positive, and that is considered also a whole number. Okay, whole number. Okay, so as you can observe, for our numerator, the term here that has variable and exponent is 3x squared. Obviously, the power is positive 2. So our numerator, that is still polynomial because we have a power of 2, that is positive integers. How about for denominator? As you can observe here, I have here square root of 2. We believe that square root of 2, that is square root of x rather. May I erase this one for a while? Okay, so when we say square root of x, so we have an index here. We have an index 2, and we have the power of x, that is 1. If you're going to convert that one in the form of power, so basically it will become x. So whatever the power of your x inside, or your radicand, that is the numerator, whatever the index in your a radical problem, that is whatever the index, that is your denominator. So basically, square root of x, that is in the form of x is equal to 1/2. So basically, your denominator, or the question is your denominator under polynomial? Basically, no, because the power is 1/2, and 1/2 is not positive integer. Yes, that is positive, but 1/2 is not an integer. That is not a whole number that you need to consider. So basically, this problem presented is not making a standard number 2 true. Okay, so meaning it is not true for standard number 2. So basically, this problem is not a rational function. Okay, why? Simply because it is not true to the second standard that we presented, that your p of x and q of x should both under the standard of polynomials. Okay, so since it is no longer in the standard of polynomials, automatically this problem, or y is equal to, let me write it again here, 3x squared plus 5 all over square root of x, is not a polynomial because your denominator, or your q of x, is not a polynomial. Okay, so that's example number 2. I do hope that that example is clear to you. Okay, so let's try this another example, or let's consider this is no longer example number 1. This is now example number 3. Okay, let's try to check if this example number 3 is a rational function or not a rational function. Same thing. The standard that I provided to you, make it sure that this is appropriate, or this is all correct to all the standards that I presented to you. Once this is correct to all the standard, automatic, that is a rational function. Let's begin. So it should be in the fraction form. So is this problem in the fraction form? Basically, we have numerator and denominator. This is under standard number 1. Number 2 is your p of x and q of x under the standard of polynomial? Okay, let's check. So for your p of x or your numerator, what is the term that has variable? Basically, that is only x. Okay, what is the power of x here? Let me zoom it here. The power of x here is 1. So meaning the power is positive integer. So that is check for numerator. How about for denominator? So that is x squared. Okay, that is x squared, ladies and gentlemen. So what is the power of x squared? Basically, that is 2. Is 2 in an integer? Automatically, yes. Basically, 2 is an integer. So meaning your p here is a polynomial and your q here is polynomial, meaning both numerator and denominator, or p of x and q of x, are both polynomials. So meaning this is now check here. Okay, so now for number 3, is your q of x is equal or is not equal to 0? Obviously, that is variable. So there are still possibilities of numbers, and x squared, it doesn't show your q of x is 0. So basically, it is under standard number 3, because we have lots of possible number when you say x squared, because we are dealing variable there. So basically, it is correct to all the standards given. So therefore, y is equal to x plus 1 all over x squared. That is a rational function. Okay, so that is rational function according to the standards provided, ladies and gentlemen. So simple thing, ladies and gentlemen, that's how we identify if it is rational or not. Okay, so just observe, make it sure that these are all under these categories or under the standards provided. If it is true to all, automatic, that is a rational function. Okay, how about this? To have a clear image on how are we going to, what they call this one, to understand rational function more, I have here another example. Okay, determine if this is rational or not. So same standard. What is the standard number 1? Make it sure that that is in the fraction form. Is this problem in the fraction form? Basically, we have a bar line dividing two different functions, so it shows fraction. So basically, it is under or correct for standard number 1. How about for standard number 2? Make it sure that your p of x and your q of x, these are polynomials. Okay, so let's observe the degree or the power of our term. So let's observe for our numerator. As you can observe here, I have 2. 2 is x squared, or squared here is an integer. This is still correct. So I have here 2x. What is the power of our x here? We have 1. So basically 1 is a positive integer. So for numerator or p of x, that is still polynomial. Let's observe whatever be in the denominator. Okay, so as you can observe here, let me erase it for you. Okay, so let's observe now. Since we already proved that our numerator is a polynomial, let's try to prove this time our denominator. So you can observe here, this is 3x, and our power here is 2, and 2 is an positive integer, and I have here 9x squared. So squared here is an integer, so basically our denominator is still polynomial. So it is correct to our second standard that our numerator and denominator, these are polynomials. So now let's proceed to our standard number 3. Okay, for standard number 2, make it sure that your q of x is not equal to 0, or your denominator is not equal to 0. Let's observe our denominator. Is our denominator equal to 0? Okay, let's try to observe. As you can observe, our denominator, it shows here 3x squared minus 9x squared. No, that is wrong. Let me, squared here is outside the parenthesis, that is 3x squared. Okay, so as you can observe, let's try to simplify. If this term here is will make the denominator 0 or not. As you can observe here, I have 3x and raised to the power of 2. Once you simplify that one, it will become 3 squared, that is 9, x squared, that is x squared. Okay, so once we simplify this term inside the parentheses, it will become 9x squared. And I have here minus 9x squared. So once you deduct this to 9x squared minus 9x squared, that is 0. So basically, in this problem, your denominator will become 0. Okay, it will become x squared plus 2x minus 1 all over 0. And basically, second standard, it says that your q of x, or your denominator, shouldn't be equal to 0. But in this problem, our denominator becomes 0. So basically, this is false or incorrect for the third standard. Since this is incorrect for the third standard, basically this function or this function given is not rational function. Okay, this is not a rational function because it is not true to the third standard provided, ladies and gentlemen. Okay, so that's how we identify a rational function. Again, for rational function, make it sure that these are true, or the given problem is true to all the standards provided for you. Okay, so this problem is not a rational function. Okay, so more practices, ladies and gentlemen. So I have here problem number 1 and problem number 2. This time, you simply identify if this is a rational function or not a rational function. Okay, so I will leave it to you this time. I will leave it to you this problem, and try to identify if this function are rational or not. And you may check the description box for the correct answer if this problem are rational or not. Again, you may check the description box of this channel for the correct answer of this following problem. Okay, so that's how we simply identify rational function, ladies and gentlemen. Make it sure, going back here, make it sure that in identifying if it is rational or not, make it sure that the given problem is true to the given standard. Once it is not true to the given at least one of the standard, automatic that is not rational. So make it sure the problem is true to all the given standards. So that's how we define rational function. I do hope that you learned something in this video in identifying rational function and not irrational function. Okay, so that's all for this video. I hope that you learned something, and to learn it even more, I see you in my next video. Again, this is Sir Robin Sanipulan, your partner learning mathematics. See you in my next video. Bye-bye!